This is 1.3 properties of numbers. The first property I'm going to talk about is the symmetric property. The symmetric property, basically, as you can see, it means A equals B, then B equals A. It kind of just switches things around. There is a chance for you to use this on like tests and quizzes and even the semester tests. So this is one of the more important ones. You will see this again for sure. But the main reason that we would use it is because we never really write our final answers as x equals 8 or 8 equals x. See, I can't even say it right. We never write it as 8 equals x. We always write it as x equals 8. So this one that I'm highlighting now, the second one, that is the correct way to write a final answer. And that's the main reason why we use the symmetric property at the end. If 8 equals x, well then x equals 8. But this is the proper way to write our final answer. The commutative property. The commutative property is basically says if you can flip things around and it doesn't change the answer, then it satisfies the commutative property. For example, a plus b should equal b plus a. For example, 3 plus 4 does equal 4 plus 3. They're both 7. A plus b, or sorry, this is times. A times b equals b times a. Does that really work? 3 times 4 equals 4 times 3? Yeah, that works. They're both 12. So that's the commutative property. It doesn't work for subtraction or division. The next one, associative property. This is kind of like the commutative property in a way, but we're not really moving things around. We're just moving our parentheses. So first we're putting in parentheses a plus b, and since we know parentheses are the first thing we have to do, that's what we would have to do first. On the other side of the equation, though, it's the b plus c that's in parentheses. We got to figure out if this will be the same answer. 1 plus 2 equals 3 plus 3 equals 1 plus 2 plus 3 is 5. So I just did the parentheses first. 3 plus 3 is 6. 1 plus 5 is 6. Those are equal. That is the associative property. It works. Let's try this one. 1 times 2 times 3. Well, 2 times 3 is 6. We're still multiplying that by 1. Equals 1 times 2 is 2. Times 3. Is 1 times 6 equal to 2 times 3? Absolutely. 6 equals 6. I'm going to erase those because we're moving on to the next one. Additive identity. Basically, the additive identity states if you add 0 to something, it stays the same, which is pretty basic, but we should just know that that's what that's called, the additive identity. 5 plus 0 is 5, 0 plus 5 is 5. Adding 0 to anything keeps it the same. The additive inverse. If I add the negative value to its positive value, it'll equal 0. For example, a plus negative a equals 0. 4 plus negative 4 equals 0. I know that's basic, but I just wanted to point that out. That's the additive inverse. That's adding its inverse. An inverse is another word for its opposite. Multiplicative identity. If I multiply anything by 1, it stays the same. Okay? For example, 12 times 1 equals 12. 1 times 12 equals 12. Again, pretty basic, but that's what that's called. Multiplicative inverse is a little bit less basic. It's a little bit more difficult to understand, but it's very useful in this class, and you will see this one again as well. So the two main ones that I show in my class are this one and this one. All the other ones are very important, and you should know them, but these two that I've started are the ones that are most important for me. With that multiplicative inverse, let's just go through what it means. So every number, even this a here, you can put a 1 under it. And I'm just multiplying it by whatever it would be if I flip that fraction around. So a over 1 times 1 over a is going to equal 1. And in fact, that's true for every fraction. If you take a fraction and then flip it upside down and multiply it, it'll equal 1. You can try that on a calculator if you don't believe me. But 7 over 1 times 1 over 7 equals 1. 3 over 7 times 7 over 3 equals 1. And I can show you just real quickly the proof for this. If I'm multiplying fractions, hold on one second. If I'm multiplying fractions, you should know you have to multiply straight across with fractions. So 3 times 7, well, 3 times 7 is 21. 7 times 3, that's also 21. 21 over 21 is 1. That's why that works. Moving on down here, now we're going to get into actually inserting numbers in for these variables. So c equals 7 and y equals negative 6. I'm just going to plug those in. Negative here, it said negative c. Well, c was 7 plus 2y, so 2 times y, but since it's a negative 6 for y, I'm going to put that in parentheses so we don't get confused and do 2 minus 6. It's 2 times negative 6, not 2 minus 6. That's why I put parentheses there. With order of operations, that means we have to do multiplication first. 2 times negative 6 is negative 12. I'm going to bring down my plus symbol. I'm going to bring down my negative 7. Negative 7 plus negative 12 is negative 19. If you add 2 negatives, it makes it more negative. So this is going to equal a 19. Moving on to the next one. Evaluate the expression when a equals 3 and b equals negative 2. Okay, so a equals 3, so there's the negative in front of a. Put my 3 in for a, plus 9, and b was negative 2. Again, whenever I put a negative number in, whenever I'm given a negative number for my variable, I just like to put it in parentheses right away. I know this is multiplication because these were being multiplied, so 9 times negative 2 is negative 18, plus negative 3. Again, I'm adding 2 negatives. That's going to equal negative 21. Scrolling down here. Evaluate the expression when y equals negative 6. So this time we're plugging in a y for both of these. So again, it's a negative 6, so I'm going to make sure I put it in parentheses. So negative 6 in for y, that was being squared, plus 5, parentheses, negative 6 for my y, minus 4. Negative 6 squared is negative 6 times negative 6, which is actually a positive 36. 5 times negative 6 is negative 30. And the negative 4 just kind of hangs on there for now. I just did all of the multiplication first because my order of operations want me to do that before I do subtraction and addition. Negative 36, or sorry, positive 36 minus 30 minus 4, that's going to equal positive 2 if I'm not mistaken. Okay, on to the last one. Y squared. Again, I've got a negative value here. I'm going to put it in parentheses right away. Negative 3 squared plus 8, plugging in a negative 3 for y again, putting it in parentheses, minus 7. That's a good start. Negative 3 squared is 9, plus 8 times negative 3 is negative 24. So it's going to be, I put the plus sign there, but I could make it a minus 24. I'll just put a minus 24 here. It's plus a negative 24 now. Minus 7. So what's 9 minus 24 minus 7? I believe that's negative 22. I hope my math's right on that. You can check me, though. A negative 22 is what I got. When you are doing this on like your Alex or whatever you're doing it for, a worksheet or whatever it is, make sure that you are writing these out. I don't care if you have to go get a notebook or something like that. I'm telling you, it's so much easier to do it when you write it out and go through the steps just like I did here. This one took me 3 steps. it does take time sometimes. So I would just encourage you to have a notebook and a pencil out when you go through.